Today, we are looking up, way, way up, to a part of our world that's always moving but is completely invisible to us. We're going to explore these incredibly powerful high-altitude winds that are silently shaping the very edge of our atmosphere. Let's dive in.
So let me start with this, just a wild thought. Right now, no matter where you are on the planet, there are these massive high-speed winds flowing miles and miles above you. And we're not talking about a gentle breeze here. We're talking about powerful jets of air, literally racing through that thin boundary where our world meets the vacuum of space.
Now, the region we're talking about is called the mesosphere and lower thermosphere, or just MLT for short. You can kind of think of it as Earth's final frontier. It's way up there, between 50 and 110 kilometers high, far above any clouds, far above any plains. This is a place where the air is unbelievably thin, and the rules of our lower atmosphere they start to break down.
So to understand this really remote part of our world, scientists have been mapping its winds for decades. And what they've found isn't just random gusts of air. No, they're organized, powerful currents, almost like invisible rivers flowing through the sky.
During the summer, it turns out there are two main jets that really dominate this region. First, you've got this powerful westward jet that flows through the mesosphere at about 75 kilometers up. But then, and get this, if you go even higher to around 97 kilometers, the wind completely reverses direction and creates an eastward jet. It's this incredible layering that makes the MLT so dynamic.
And when I say these winds are fast, I mean they are really fast. At its peak, that lower westward jet has been clocked at speeds of up to 54 meters per second. Now that number might not mean much, so let me put that into perspective for you. That is over 120 miles per hour. That's basically a Category 3 hurricane. But it's all happening in a part of the atmosphere that's practically a vacuum. It just tells you that there's an immense amount of energy being moved around way up there.
But okay, here's where the story gets really interesting. These invisible rivers of air, they aren't static. Decades of radar data have revealed that they are slowly but significantly changing.
So using over 30 years of data from radars in Germany, scientists have found a really clear trend at the middle latitudes. That powerful westward jet, the one screaming along at 120 miles an hour, it's actually getting stronger.
And you can really see that change right here. If you compare the average peak wind speeds from the early 1990s to today, there is a measurable increase. And this isn't just a random blip. It is a persistent, long-term trend.
But at the exact same time, when scientists looked at data from way up at high latitudes, over Norway, they found the complete opposite trend. The higher altitude eastward winds are actually getting weaker. So you've got winds getting stronger in one place and weaker in another. What in the world could be causing this?
Trying to figure out the forces behind this 3-decade shift is really the central mystery here. We're talking about changes happening on a planetary scale.
Just think about that for a second. What forces are powerful enough to reach up 100 kilometers into the sky and physically change wind patterns that have probably been stable for thousands of years? Well, the answer isn't simple. It's a mix of things from both above us and below us.
Researchers have basically lined up three main suspects. First, there's the sun's 11-year cycle of activity. Second, geomagnetic storms, these huge eruptions of energy from the sun that slam into our magnetic field. And third, something called atmospheric gravity waves. These are basically ripples of energy that travel up from weather systems far, far below, kind of like waves spreading across the pond.
What's so fascinating is how these forces have totally different effects in different places. Take geomagnetic storms, for example. At high latitudes, like in Norway, these storms actually give the eastward wind a boost, making it stronger. But down at middle latitudes, over Germany, the same storms do the exact opposite. They weaken both of the wind jets. It's an incredibly complex dance.
But here's the thing. While the sun and its storms definitely play a role, they don't explain the whole long-term trend. To find the real underlying cause, we actually have to connect these changes to something happening right here, on the surface of our planet.
And this brings us to the biggest question of all. So what, right? They're invisible winds, miles over our heads. Why should any of us care if they're getting a little stronger or a little weaker?
Well, we should care because, as the source research for this explainer puts it, these winds are a very sensitive indicator of the human footprint on our environment. The changes happening in this remote, alien layer of the atmosphere are a direct reflection of the changes we are causing down here.
Okay, so here's how that connection works. While greenhouse gases like CO2 warm the lower atmosphere, we all know that, they have this counterintuitive opposite effect way up in the MLT. They cause it to cool down and contract. So this physical change in the atmosphere structure actually alters the path of those gravity waves traveling up from our weather. The waves then drop off their energy differently, and that, in turn, is what's changing the speed of those high-altitude winds.
So, the crucial takeaway here is this. Studying these upper winds isn't just some abstract physics problem. It's about understanding the fully interconnected system of our entire planet, from the ground all the way to the very edge of space.
You know, the authors of the studies said it perfectly. The Earth's atmosphere constitutes a complex and dynamic system. Nothing happens in a vacuum, no pun intended. The CO2 we release on the surface is physically reshaping the dynamics of the atmosphere 100 kilometers up. And these shifting winds, they're the proof.
Which leaves us with a final, pretty profound thought. These winds are like a sensitive barometer for global change, a message that's being written in an invisible medium. And the question we really need to keep asking ourselves is, what else are they trying to tell us about our changing planet?